Okay, so this video is just a little bit about basic waves, so just recognizing how we can interpret waves and the language that's used to describe them. So the first thing is when we're talking about waves, the main thing that we often talk about is the wavelength given by the symbol lambda. Okay, so a wavelength would be if we're dealing with something that is being on a distance graph, so we've got like displacement versus distance, for example. So in this case, the wavelength, okay, is the distance it takes for one complete wave. So one complete wave would be one up and one down. So it would be this length here. Now often that's a little bit trickier to kind of spot that. So sometimes we take it as the peak to the peak. Okay, so one wave to the identical place on the next corresponding wave, okay, is equal to the wavelength. And wavelength is measured in meters. The other thing that we have is if this is again on a displacement graph, we've got again meters going up here, we can talk about the displacement of it. So as the wave is going through, it's going through different displacements, okay, coming up from the mean or equilibrium position. Okay, so this is sometimes known as well as the rest position. And these little ones here would be just how far it's displaced away. But when we get to its maximum displacement, okay, so maximum displacement, which is x naught, all right, also can be sometimes given with the symbol A, all right, that is the amplitude. Okay, and being really careful, it's only starting from that rest position, so it's just to the highest peak. Okay, and again, these are known at the tops, okay, peaks, or sometimes people call them crests, and at the bottom they are known as troughs. So sometimes as well, we don't always have a displacement distance graph, we sometimes have a displacement time graph, okay, and with our time being given in seconds. So in this case, this would not be the wavelength, all right? This would be the time it takes for one complete oscillation. So we call this the time period, okay? So the time period, okay, is the time it takes for one complete oscillation. Okay, and again, we're given that in seconds. Now the one that we can't really represent on this graph is the frequency, but the frequency is how many waves appear in 1 second. Okay, so we can also look at frequency. Okay, so basically how many waves, okay, I should be able to say oscillations here as well, are in 1 second. Okay, so this again is given by the relationship F is equal to 1 over the time period, and time period therefore is equal to 1 over frequency. Frequency is measured in hertz. Now, because hertz is 1 over the time period, we also say that hertz is equal to seconds to the -1. So that's kind of it within its SI units there. Other little things as well in terms of the wave. Okay, amplitude is the maximum displacement, and x is just displacement. So that is just the basics of waves in terms of language and simple frequency and time period oscillation. We also have another equation that we can use with waves. Actually, we have two. So we have two different ones for measuring wave speed. So we can say that c is equal to f lambda. Okay, in this case, c would be meters per seconds. Okay, our frequency is in hertz. Oops, I missed my z there. And our lambda is in meters, so our wavelength. So speed is equal to frequency times wavelength. The other one as well to watch out for is we can also use the speed is equal to distance divided by time equation as well. So sometimes, for example, let's say you have a boat and the boat is giving off, let's say, an ultrasound that's trying to measure the depth of the sea floor. Okay, it sends out a wave with V, and then it's going to reflect and it's going to travel back up. Okay, so speed is equal to distance divided by time. So therefore my distance is equal to speed times time. If we measure the time, okay, and we know the speed of the wave, all right, the distance is going to be the two multiplied together. If we wanted to work out the distance of the seabed, we would just have to half that answer. So most of the time we actually use this equation, but occasionally the IB do throw in these little kind of speed, distance, time ones to just kind of get you to think outside of the box a little bit with that one. So that's just again a little bit on wave basics.